Hello friends, welcome to the channel All Competition. In the last lecture, we have seen what is meant by proof and some types of proofs. In today's lecture, we are going to discuss what is meant by proof by induction. So proof by induction, which is a advanced method, it is an advanced method as well as which is applies on infinite set. It is advanced method and applies on infinite set. So let us take one example, summation of natural numbers. Okay, so let us consider 1, 2, 3 up to n. We have taken first n natural numbers, and what will the formula for that? 1 plus 2 plus 3 plus up to n, which will be equals to simply summation n is equals to 1 to n in bracket n plus 1 upon 2. That we have to prove by using induction method. Also, some other formulas are like this: 1 square plus 2 square plus up to n square, which is nothing but summation n is equals to 1 tends to n in bracket n plus 1 2n plus 1 divided by 6. That is for summation of square of first n natural numbers. Okay, and the last one, 1 cube plus 2 cube plus n cube, which is n square n plus 1 square divided by 4. So these are the formulas which is comes under proof by induction method. Out of that, we are going to discuss the first formula. Okay, so let us see that. So as we know that the induction step and basic steps, these are the two steps which is comes under proof by induction. Okay, so the first one, basic step. So what is the basic step? If n is equals to 1, then we can take summation of n is equals to 1 tends to 1, which will be n in bracket n plus 1 divided by 2, which is nothing but 1 in bracket 1 plus 1 divided by 2, which is simply 1 in bracket 2 by 2, which is equals to 1. That is the equation number 1, and this one is the basic step. And by using this basic step, we can go for the next step, that is the induction step. Okay, so what is the induction step? If n is equals to 2, then if n is equals to 2, then what is the meaning of this? Simply we are going to take the summation of 1 plus 2. Okay, so 1 plus 2 means summation n is equals to 1 to n, and here we will be take this formula again, n in bracket n plus 1 divided by 2, which will be gives you 2 in bracket 2 plus 1 divided by 2, which is equals to 2 into 3 divided by 2, which gives you 3. Okay, but instead of taking this directly, we have to use this formula and we have to show that this one is correct. So how to do that? Let us see. So in the case so in the case of induction step, so as I have taken here n is equals to 2, means what? It is 1 plus 2. So you can write this as a, which is same as summation n is equals to 1 to 1, then n in bracket n plus 1 divided by 2 plus 2. So you can clearly see here what I have did here. I have taken the basis step as it is plus 2. So what is the resultant for this? So the resultant for this is this one. So you can see this 1 in bracket 1 plus 1 divided by 2 plus 2. So simply what will be the operation over here? Simply see, this one will be as it is, this one will be as it is, then in bracket 2 plus this 2 will be multiplies over here, okay, and divided by these 2. Fine. So you will be right here, this 2 will be take common, this 2 will be take common, in bracket this 1 plus this remaining 2 divided by 2, which is equals to 2 in bracket, you can see 2 in bracket this 2 plus 1 divided by 2. So you can see this is nothing but in the form, this is nothing but in the form when 1 plus 2, then which is same as summation I is n is equals to summation n is equals to 1 to the 2 n in bracket n plus 1 divided by 2. Hence we have to do this. Okay, so that is the basic idea with respect to the proof by induction. Let us take another example over here. So as have know that 1 plus 2 plus up to n, which is equals to summation n is equals to 1 to the n in bracket n plus 1 divided by 2. We know that this formula with us, and also we have proved that in the previous two things, that is n is equals to 1 and n is equals to 2. So let us see here, if n is equals to k, if I take n is equals to k, then it gives me formula as a k in bracket k plus 1 divided by 2. So that is the equation number 3. Now if we take n is equals to k plus 1, what is the meaning of this? It is nothing but summation of first k plus 1 natural numbers. So what is the meaning of this? 1 plus 2 plus 3 plus so on up to k, that is the second last number, plus this is last number under this discussion, that is n is equals to k plus 1. So already we know that this one, if n is equals to k, then k in bracket k plus 1 by 2. Hence for this I will take here k in bracket k plus 1 divided by 2, and then I will take here k plus 1. So let us say this as an equation number 4, and if I simplifies the equation number 4, then it will be gives me k in bracket k plus 1 plus twice of k plus 1. Simply I have multiplied these 2 over here divided by 2. Fine. So if I going for the simplification of this equation number 5, I'll be got here k plus 1 as a common. Okay, this k plus 1 and this k plus 1 I will take as a common, and k from here and 2 from here will be take here divided by 2. So simply it is nothing but k plus 1 in bracket k plus 1 plus 1, that is in another bracket, divided by 2. So for n is equals to k plus 1, n is equals to k plus 1, we have proved that k plus 1 in bracket k plus 1 plus 1 divided by 2, that is the formula by using induction method. Okay, so that's all about today's lecture, that is proved by induction. I hope that you got this idea. Also, at the beginning of this lecture, I have given you that summation of square of first n natural numbers or cube of first n natural numbers, and with respect to that some formulas are given to you. Try for that. If you want to solve that, please mention in the comment. Thank you so much.